The next part of the geometry chapter deals with area, surface area. Area is something that we talked a little bit about earlier in the year in circles, and you should have done a little bit more of this last year. When we're finding areas of polygons, there's four things we need to do. The first thing is write the formula we're using. That's determined by the shape. The next thing that we do is we substitute the numbers into the formula that we know. The third thing is we solve that formula with our substituted numbers by using our calculators. And then step number 4, make sure we label our answer with the proper label. If we're talking about area, it is always something squared. So it's feet squared, inches squared, meters squared, because it's two-dimensional. This table here is all the formulas that you need to know. A square is where each side is the same length. So if it's 5 on one side, it's 5 all the way around. Our formula for that is A equals S squared. Or we could write S times S. Either way, we're taking that one side and multiplying it by itself. Some people still use the formula length times width, which technically it's not wrong, but a square is a special rectangle, so we give it a special formula. A rectangle, on the other hand, has a length and a width, the longer side on the bottom being the length usually. The width could be longer than the length, it's possible, and the width is on the side, and the formula for this area is equal to the length times the width. A parallelogram looks like a rectangle that's been tilted a little bit. The base is the bottom side, and when they give you a parallelogram, they'll always see like a dotted line and a right angle. So the height of the parallelogram and the base make a right angle. So they give you all kinds of numbers. Always look for the right angle. See what two numbers make that up. That's the base and the height. If you notice, if I took this dotted part off of here and I slid it over to the other side and connected it, it would look something like that, and now I would have created a rectangle. The formula is very similar to a rectangle. I don't have a length and width though in this time, but I do have a base and a height. And notice in a rectangle, the right angle is made by the length and width, and in the parallelogram it's made by the base and the height. Triangles can look all kinds of different ways. We could have a triangle that looks like this. We could have a triangle that looks like this. We could have a triangle that looks like this. It's similar to a parallelogram. There's two sides that make it. The base is the bottom side, and the height is how tall the triangle is. And if you notice, that will create a right angle again. So the base and the height create the right angle. And because these are only half of a parallelogram, it's not a whole one. If I took that triangle and copied it, tipped it upside down and attached them, I could make a parallelogram. So our formula is half of what a parallelogram is, so 1/2 base times height. Or you might see base times height over 2. That would be the same formula. A trapezoid is a rectangle with two triangles attached to it. Sometimes it's just a rectangle with a triangle attached to it. I could show you where the formula comes from. It's kind of lengthy though. So a trapezoid could look something like this. That's called a right trapezoid. Or you'll see it sometimes like this. The height again is the distance between the two bases. And there's two bases because the top of this and the bottom of this are different lengths. So we have to distinguish between those two. The formula is half of the height times parentheses base 1 plus base 2. So you add the two bases together, the two sides that are parallel, multiply that by half of the height. A circle we did earlier in the year. The radius is the distance from the center to the outside, and the formula that we used was A equals pi r squared. Now you might be saying to yourself, well, I remember doing circumference or pi times the diameter. That's circumference formula. That's like perimeter. So some examples for these, in case you're going along and need some assistance. This is a parallelogram, so we're going to use the base times height formula. The base is the same as the top as it is in the bottom, so that's 12. The height is 9. I would multiply these two together, get 108, and my label is inches squared. B, there's only one side labeled, so we're going to assume that this is a square. A equals s squared. The side of this is 2.6. I square that in my calculator, 6.76, and then the label is centimeters squared because it's area. So there's two of our shapes we talked about. Letter C is a rectangle, so length times width is our formula. The length of this is 4.5. The width, how wide it is 3/4. Using our calculator again, we can multiply those numbers. 3 3/8 feet squared would be our answer. Letter D is a triangle. Notice the right angle, the base and the height make that. So 1/2 base times height is my formula. I'm going to substitute in my numbers. The base is 10. Height is 7.5. Half of 10 is 5 times 7.5 is 37.5 millimeters squared. Letter E is an example of a trapezoid. So 1/2 the height times base 1 plus base 2. Doesn't matter which one you call base 1 or base 2 because 9 plus 20 is the same as 20 plus 9. The height, though, is the one that's between the two bases. So 1/2 15 times 9 plus 20. And if I were to do this in my calculator, 20 and 9, that's 29 times 15, and then half of that is 217.5 meters squared. Letter F, I could use the trapezoid formula for this question, but you could also break a trapezoid apart. Usually in the middle, like here, it's a square or a rectangle. In this case, it's a square. So if I find the area of this piece, A equals s squared, 5 squared would be 25. So that's the middle piece, 25. Over here, I have a right triangle. The base is 4, and the height is the same distance because it's a square all the way around. So that's 5. So 1/2 base times height. Half of 4 times 5 is 10. And this one over here has a base of 3 now and a height of 5. So 1/2 3 times 5. So half of 15 is 7.5. So if you notice, I could, at times, given enough information, break apart a trapezoid to make other shapes and then add these shapes together. So what I would do is add the three pieces together. I have 7.5, 25 plus 10, which gives me a total of 42.5 centimeters squared. So if you notice the amount of work it took me, letter E is a lot easier. It's one formula, plug the numbers in, and I get what I need. I wanted to show you though it's possible to do it a different way. Number 2, is it possible to use one formula of area to find the area of this regular hexagon? A regular polygon has congruent side lengths and angles. This really is, if you look at this shape here, we could cut this like this here. So really this would be 6 triangles. We could cut it other ways too, instead of like that, but if they're telling us the size of that triangle, then what I would do is find the area of that triangle, 1/2 base times height. The base of that, the bottom is 6. The height, how tall it is 5.2. And when I plug it in my calculator, half of 33. Not 33, I apologize. Half of 6 is 3 times 5, 15.6, and if you notice I have 6 triangles here, so we're going to multiply that by 6 triangles, and we're going to get 93.6, and it doesn't tell us what the value, or the label is, sorry, so we'll just call it units squared. So this would be the area of this whole hexagon. Again, we could break it into pieces. Number 3, a landscape contractor looks at a scale drawing of a yard and estimates that the area of the home and the garage is the same as the area of a rectangle that is 100 feet by 35 feet. He comes up with 5,500 feet. How close is this estimate? I'd like you to try that question. Notice it's a rectangle and we're using area, and see if he is close or not.